This is lesson 7 continued. In this video, we are going to talk about the different methods you can use for finding a solution to a system of linear equations in two variables. There are 3 methods that I'm going to talk about. The first one is graphing, the second one is substitution, and the third one is addition. So 2 and 3 are algebraic, number 1 is graphing. So if you recall in the last video, the graph can do one of 3 things when you graph a system of 2 equations. It can intersect, the lines can be parallel, or you can have overlapping or the same lines. So you can graph a system of equations to see which one of these applies. So just to fill in the blanks, graph the lines to see where the lines intersect. That point of intersection is the solution to the system. However, if the lines are the same, or another way to think of that, overlapping, you have infinitely many solutions. And we'll talk about how to give the solution when I solve one of those problems. So you need to be a little more specific than just saying infinitely many solutions, but I'll give you an example in just a minute. And then remember, the third thing that can happen is the lines can be parallel, and in that case you have no point of intersection, so there is no solution. Whoops, sorry. So the steps to solving algebraically are listed below, but I'm not going to read through them now. I'll kind of talk about them as I work each example. The reason we need different ways to solve an equation other than just graphing is because sometimes graphing is not exact. For instance, let's say you get a point on a coordinate plane and you're not exactly sure. Maybe the solution is 1.5, 3 2/3. So if you're graphing that, unless you have a coordinate plane that breaks down your units into halves and thirds, it's going to be hard to know exactly what that solution is. So you'll be estimating the solution. However, if you're solving algebraically, you will get an exact solution if one exists. So let's go to the next page and let's look at how we can solve these systems. So if you look, numbers 3 and 4 give you the same system. So we have the same 2 equations. And if we were to graph these equations, this is what the graphs look like. So we do see that there is a single solution here. And it looks like the solution is -1, 2, 3, 4, positive 1, 2, 3, 4, 5, 6. So this is an example where graphing would give you an exact value. However, we can also get this value by using what we call the substitution method or the addition method. Another name for the addition method is called the elimination method because it relies on you eliminating one of the variables. So with the substitution method, what you're going to do is pick one of the equations, either equation 1 or equation 2, and solve for one of the variables. Now, sometimes you can make a better choice of which equation to pick and which variable to solve for. So if we look at both of these equations, I'm thinking it would be better to pick equation 2, and we're going to solve for y. Can you think of a reason why I would choose equation 2 in solving for y? If I take this equation, 5x minus y equals -26, and I solve it for y, The first thing I would do is subtract 5x from both sides. And that's going to give me negative y is equal to negative 5x minus 26. And then the last step would be to divide by negative 1. And that's going to give me y is equal to positive 5x plus 26. Notice that when I solve for y, I did not get any fractions. And we don't like to work with fractions. You can, but it's just sometimes not fun. If I had picked equation 1 and solved for x, I would have gotten a fraction when I tried to divide 3 by 2. Same thing if I tried to solve for y, I would have gotten 2 fractions when I tried to divide 2 and 10 by 3. And here, if I had picked equation 2 and tried to solve for x, I would have gotten a fraction when I tried to divide 1 or negative 1 and then negative 26 by 5. So that's why I picked equation 2 and I solved for y. So one note you want to make is maybe look for the variable that has a coefficient of 1. All right, so for substitution, maybe we'll make this note. When picking which equation and which variable to solve for, look for a variable. With a coefficient or the number in front of 1 or negative 1. And that will help you avoid fractions when possible. Not always possible to do that, but when you can, it might save you some frustration. All right, but we don't have the solution to the system yet. So what you're going to do now is you're going to plug this in equation 1 or the other equation. So since you picked equation 2 here, now you're going to go to equation 1. So I'm going to look at equation 1, which was 2x plus 3y equals 10. But instead of y, I'm going to plug in what I got for y. So I'm going to plug in here 5x plus 26. So you take what you got in your first equation and plug it into the other equation. Okay? The reason you do this is because now you have an equation with only one variable, x, in it. And when you have only one variable, you can solve for that variable. So, if I take the steps to solve for this variable, I'm going to have 2x plus, and then I need to distribute that 3. So that's going to give me 15x plus, let's see, 3 times 6 is 18, 3 times 2 is 6, 78 equals 10. Now I can combine like terms, and so that's going to give me 17x. I'm going to subtract 78 from both sides, and that's going to give me negative 68. And then if I divide both sides by 17, guess what you get? X is equal to negative 4, which we already knew by graphing, but I'm just showing you how you can arrive at the same answer using substitution. Now that just gives me half of my solution. I also need to find y, and the best place to find y is right here because I've already solved this equation for y. So this is the nice thing about the substitution method. Let me maybe number these steps because it's getting confusing. So this is step 1. Then this is step 2. And then step 3 is find y by plugging x into the equation from step 1. Now that's the danger of the substitution method, is you're going back and forth and back and forth. So it's really easy to get confused about which equation you're working for. So just try to keep track of where you are, and that will help you make sure you're not getting mixed up. So I had y is equal to 5x plus 26. I know that x is equal to negative 4, so I'm going to put these together now to find y. So y is equal to 5 times x plus 26, but I'm going to plug negative 4 in for x. So y is equal to negative 20 plus 26, which is 6. So now I have my solution, which I already knew, and if I hadn't already, in ALEKS and for me, you're going to write that solution as an ordered pair, making sure you put x first and y second. In the next video, I'll show you how to solve this same system by using the addition method.